All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be doing some Rust studies. And today everything seems to be going well so far, as compared to yesterday, where I was having, some tech issues and the stream crashed, and well, my system kind of froze, because of which I had to crash the stream. And yeah, there was just a bunch of issues going on. And today is one of the rare occasions where I actually managed to start the stream relatively early. If I'm able to, then I am probably going to go for maybe 2.5 hours today. If everything goes well, if everything remains well. And yeah, we are just taking a short detour with Rust. Short detour from what we were doing before, which was Le Robot. Yeah. So I just wanted to spend some time, finishing off the Rust basics, because it's one of those situations where I've kind of gotten comfortable with the language. Like at this point, I am comfortable with the language. I've done a bunch of things in the language. It's no longer about me remembering the syntax. I'm also a lot more comfortable with the memory safety related things, stuff like dealing with the borrow checker, for example. I'm comfortable with the language itself. It's more so about exploring more advanced language features, just so I can get better at the language. I want to explore these higher. I don't know if I should call them higher level, but these more advanced language features, which are still basics, by the way. I'm calling them advanced language features, but they're advanced, but still within the basics category. Like these are basic language features, basic Rust features that you should know, but like in the basics category, they are more on the advanced side. I don't know why I'm going into so much detail with that. Anyways, this I'm spending some time. Actually, okay, I'm in this thing, right? Hold on. Here. So I'm gonna go all the way up to this conversation. I believe in this case I had started the conversation. I had to stop it elsewhere. I don't remember what the reason was that I had to stop it, and I didn't know too much about Gemini at the time to be able to like properly port it over to. I think I'd moved it over from one machine to another, and I didn't exactly move it. What I did is I changed up the prompt. So this was a big prompt that I had made, saying that, you're a tutorial creator, you're going to teach me Rust. I already know the basic syntax. And then I asked it to create like I'd asked it to create like a syllabus for me. And I think from a previous conversation, I had the JSON version of that syllabus, if I remember right. Let me see what I'd written here. So that part is covered. What I need to learn is everything after that. You have already generated a syllabus for me containing chapters going from basics to advanced. Here's the syllabus serialized in JSON. You can deserialize it to present it as a proper list with topics, subtopics, etc. So this is the JSON that I provided. This is actually the JSON that the other Gemini CLI instance had generated for me. So this is our entire syllabus. Um, it has, I think, 15 chapters. I don't remember. Yeah, it has 15 chapters. And of the 15 chapters, I believe I was already at chapter 5 or 6. I don't remember. I think I mentioned it somewhere here. Uh, I was mentioning like the basic stuff that it has to do. You will load chapters one by one when instructed to do so. When a chapter is loaded, I want theory, an explanation, and then an exercise program for practice. The example program is very important. You know what's interesting? Initially, when I when I had started doing this course sort of thing where I create a prompt for Gemini to build a course for me. Initially, when I had started doing this, the idea was supposed to be that I'll try and get through one entire chapter in one day, or in this specific case, I believe I had mentioned that I only have about an hour. Yeah, I mentioned I only have like 30 to 60 minutes to work on this entire thing, or rather 30 to 60 minutes a day to spend on learning Rust. So I'd asked Gemini to, you know, prepare the syllabus and format everything and provide a certain amount of information, keeping that in mind. But now that has kind of changed, and I'm not really doing that, one chapter a day kind of thing. I'm still following the exact same syllabus, and it just so happens that this syllabus that was made to be short and simple enough for that, one chapter a day thing or 60 minutes a day thing, it just so happens that this still seems to be working out well for me. And I think in the future, actually I did make a bunch of other such prompts as well, where I asked Gemini to prepare courses for me, and I have a bunch of these courses like lined up. One of them is the electronics one that I want to do. I'm definitely going to be doing that. I have to set up a webcam for that, and at some point later, once I'm more comfortable with ESP32 programming, I want to flash the. Actually, I don't think I need to flash the firmware. I think it's specifically the library that I need to, the crate that I need to import. Somebody has made a crate for ESP32 CAM or ESP CAM. I don't remember exactly what it's called, but somebody has made a crate for that, and so I'm gonna be using that. I have like one or two ESP32 cams, so I can probably set up like my own little webcam kind of thing over here. It doesn't have to be specifically. I mean, I already have a proper webcam. I have a Razer Kio, which is it's pretty high quality. So I can just get started using that, and it's working perfectly fine as well. So like, I mean, if I want, I can get started with that. What I want to do with the ESP32 cam though is I want to capture the images in low resolution. Let's say, I don't know, 1024 by 768. I don't know. I'll have to see what a nice small resolution, and what resolution is small enough but nice enough that it's still, the details in the video are still clear. And in this case, the details that are necessary is being able to see the components and the breadboard and stuff like that. It's going to be a very small area that needs to be captured anyways, so I can keep the resolution relatively small. It doesn't need to be very high res, and because of that, the processing load is probably going to be much, much less. To be fair, I believe I can change those settings in my Razer Kio webcam as well. I could be wrong about that. I'm going to have to check what's the situation surrounding that. But yeah, there are a bunch of settings that you can do. There's a bunch of configuration that you can do for the Razer Kio. Uh, I'll have to see to what extent I can customize the resolution. And I'm pretty sure if I set the resolution to be lower, then it's going to be consuming less resources. But yeah, this is one of the projects that I want to work on, which is a ESP32 cam. And just as a practice kind of thing, I want to create my own webcam that I can connect to my computer and stream off of. The way that I'm planning on setting it up is it's not going to be it's not going to be directly recognized as a webcam source, because there's a bunch of extra stuff that I would need to do for that, and I don't want to do that. What I'm going to do is the ESP32 cam is going to be connected to my computer either via wire or via Wi-Fi. I'll have to see which one I want to go for. Wire seems like a much better option, especially in this case, because I would be able to get much more data through in how should I say that? The data transfer rate would be much faster. Let's just say that I would be able to get much more data through per second with a wired connection versus a wireless connection. Now, what I need to check, what I need to see is that really gonna make that much of a difference? Like, is the Wi-Fi connection gonna be so slow that I'm gonna be noticing like a very noticeable lag, or is it that, I mean, it's obviously going to be slower than a wired connection, that's for sure. But is that slowness uh, going to be so impactful that I'll actually notice some kind of latency, or is it negligible? Is it insignificant? That's something I'll have to test out. I was also planning on doing a certain amount of processing on both the ESP32 and on the PC side, just to improve the connection kind of situation. So that way I would not need to have a wired connection. I could do it wirelessly. And my idea was I'll capture the image frames and then use some kind of so this is going to be only video. There's no audio included, so it's not like a container. It's mainly image frames, right? I can I can pack this up into a container if I need to, but in this specific case, it has to be like a streaming kind of situation. It doesn't even have to be like a container kind of situation. Uh, Actually, you know what? I should ask Gemini about this. So, okay, my idea, which just now, like, I'm thinking about how, okay, so the idea was that I'll capture the image frames on the ESP32 cam, and then I'll apply some sort of compression to it, some kind of encoding to it, just to make the data smaller. And then that data is going to be sent over to, it's going to be sent over to actually, I think first it's going to be packaged into like a smaller format, like maybe message pack, I guess. I'll have to see which specific one is suitable for this purpose. But yeah, I the idea was that I'm gonna compress it down and pack it, and then this data is gonna be small enough so I can then send it over the network, and it'll be received fast enough. And then on the other end, we're gonna unpack the thing and decompress and whatever all decode and whatever else needs to be done before it gets displayed on the screen. So that was the idea initially, right? And now that I'm thinking about it, I I'm realizing that okay, because this is supposed to be like a live connection kind of thing, it's not that the ESP32 is recording and then saving the frames into a video file or anything. No, it's quite literally recording those frames or generating those frames, capturing those frames, and we have the live frames right there, so we can like transfer them immediately, right? Keeping that in mind, I could try to use some kind of streaming protocol or some kind of streaming related codec, right? So I need to ask this question to Gemini. So just give me a second while I set up that prompt, and then we can continue with the Rust stuff. Okay. Hey, so I have um, a project in mind. Um, I'm gonna build a webcam using ESP32 cam and Rust. The idea is I'll capture the frames on the ESP32 and then send the frames either over serial or Wi-Fi over to a program running a Rust, I should mention, a Rust program running on the PC, and then the frames get displayed there in some sort of image or video viewer embedded within the program. What I'm wondering is what would be a nice optimized way to do this, keeping in mind that it's mainly streaming the video from the ESP32 to the PC, not recording and not recording frames and placing them into a container. Because I'd imagine there are optimized streaming protocols and encoding methods I could use that would make the data small enough that even if the data was going over Wi-Fi rather than serial, it would still be fast enough. Okay, building a streaming webcam with an ESP32 cam and Rust is a fun challenge. Since the ESP32 cam lacks a hardware encoder, the standard approach for performance is MJPEG, Motion JPEG, while H.264 provides better compression. Oh God, what did I just do? What just happened? Oh, okay. Where was I? Yeah, while H.264 provides better compression, the ESP32 doesn't have the CPU cycles to encode it in software at any decent frame rate. Hold on just a second. It mentions here that the ESP32 doesn't have enough CPU cycles to encode it in software at any decent frame rate. What if I introduced an extra ESP32 as a hardware encoder? Yeah, yeah. What if I did that? Because I do have an extra ESP32 lying around, so I could introduce a second ESP32 into the equation, and then though I'll have to see how, because like okay, when I do introduce a second ESP32, we would have to have a parallel connection, right? The ESP32 itself, the ESP32 cam, I think its hardware is already going to be really busy working, with the cam. So what I could do is any data that's captured on the ESP32 cam, we can send it over a parallel data bus over to another ESP32 where it can actually be processed or encoded or whatever, and from there it can be sent. I'll have to look into that. Yeah, I'll have to look into that. The ESP32 doesn't have the CPU cycles to encode it in software at any decent frame rate. Here's the most optimized way to architect this setup using Rust. the transmission protocol, UDP versus TCP. For live streaming, where you care about speed over perfection, UDP is generally superior because it doesn't wait for lost packets, avoiding ahead of line blocking, which causes lag. Option A, an HTTP multipart TCP. This is the easiest. The ESP32 hosts a web server and sends a continuous stream of JPEGs. It's robust but adds overhead. Oh yeah, I remember that thing about HTTP. Holy shit, dude. Yeah, I don't know if I spoke about this on stream, but like I was doing some research on how to get like a very simple web feed from an ESP32 over to like a web server. And apparently HTTP does have one multimedia sort of setting, because you can send different types of media over to over HTTP. And one of the settings there, it allows you to set up a sort of video stream where the page doesn't really close the connection. It keeps it open, and anytime you change the image, it kind of reflects that on the web page. So you can use like a raw web page to just show one video. But this is if you're displaying the video on like a web page. In my case, I'm not doing that, so I'm gonna have to let me see. Okay. Option B is raw UDP packets, which is optimized. Send each JPEG frame as a series of UDP packets. You'll need a simple header for each packet so the Rust PC app can reassemble them. Frame ID, packet index, total packets, data, etc. Okay. Encoding strategy. The OV2640 sensor on the ESP32 cam can output JPEG directly in hardware. This is your quote unquote compression. Resolution, keep it at VGA 640 by 480 or SVGA 800 by 600 for a balance of quality and FPS. JPEG quality, a setting of 10 to 12 in the sensor T config provides a good 10 to 12 what? Okay, maybe that's like a quality level, I guess. Okay, DMA buffering. If you use the ESP camera driver, ensure you are pulling from the frame buffer as fast as possible. The Rust PC application. On the PC side, you need a high performance way to decode and display. Decoding is you use the image crate or turbo JPEG to turn the JPEG bytes into a raw pixel buffer. Okay. And then display slash UI, you use EGUI or ICE. Great if you want a full GUI. You can update the texture every frame. No, you can update the texture every time a new frame arrives. Okay. Why not serial? While you mentioned serial, standard ESP32 UART is usually capped at 115,000 to 921,000 baud. A 640 by 480 JPEG is roughly 20 to 40 KB. At 921,000 baud, you would only get 2 to 4 frames per second. Wi-Fi UDP can easily give you 20 plus frames. I didn't realize that was... Holy shit. Okay. Wait, that's crazy. Okay, hold up. Okay, a couple of questions. Wait, so this is wild. Wi-Fi would actually be able to send more or send data faster than serial. I guess here it's more about how much data can be sent at once rather than just how fast the data can travel. That's a question. Then, in terms of streaming, I was hoping there might be some type of system in place that I could use where I just set up a client and a server and some sort of streaming protocol that includes the encoding would be used. Is there no such thing? I don't mind doing the work manually, but I was wondering if there was a more standardized way that people use. My idea was to eventually display, wait, as far as displaying is concerned, I was planning on using some sort of graphical application to display the image. Probably something like Nano, maybe, or something much, much simpler that just draws a GUI window and an image which keeps changing inside it. Okay. It's a bit of a brain bender at first, but Wi-Fi on an ESP32 is significantly faster than Serial for this specific task. Wi-Fi versus Serial. Why Wi-Fi wins? It comes down to throughput, bandwidth, rather than the physical speed of electrons. Okay, so I did not take that into account, that how much data is it going to be able to send at once. I was only taking into account that the data is going to travel much faster over the wire. I wasn't taking into account that in both of these cases, which one is able to send the most amount of data at once. I guess something that I was assuming was that it's gonna chunk the data, as in split up the data into pieces and like send those pieces over. But I guess that's not what's happening. Okay, serial UART standard ESP32 serial usually tops out at 90 at 921k bits per second. After overhead, you're looking at roughly 80 to 90 kilobits per second. A single VGA JPEG frame is often 30 KB. At that rate, you'll struggle to hit 3 frames per second. That's crazy. Okay. All right. Wi-Fi, even on an older ESP32, you can achieve 10 to 20 megabits per second of actual data throughput fairly easily. That's roughly 1250 to 2500. Oh, okay, so that's roughly 1.2 to 2.5 MB per second as compared to 80 to 90 KB per second. This is more than enough to stream 20 to 30 frames per second at VGA resolution. Standardized streaming protocols. Yes, there are standardized ways to do this, so you don't have to invent your own packet format. RTSP, real-time streaming protocol. This is the pro way. It's what security cameras use. How it works. The ESP32 acts as an RTSP server. Pros, you can open the stream in VLC, OBS, or in, oh, OBS as well. Okay. In, wait, where was I? Yeah, you can open the stream in VLC, OBS, or any standard player. Cons, implementing a full RTSP server in Rust on an ESP32 is complex. Most people use C-based libraries like ESPCam, RTSP, and wrap them. HTTP MPEG streaming, the browser way. This is the most common quote-unquote standard for DIY projects. How it works, the ESP32 sends a single HTTP response with a content type multi-part slash x mixed replaced. X mixed replace. This is by the way what I was talking about. This is the thing that allows you to do the words. This is the thing that allows you to create a sort of video feed kind of thing. Right. It then just keeps dumping JPEGs one after the other. Rust implementation. On the PC side, you use a library like request to open the stream and a simple loop to split the incoming bytes whenever you see the boundary string. Okay. Displaying in Rust Nano versus simple GUI. Using Nano is a great choice because it gives you a high performance draw loop. Here's how that optimized flow looks. Network thread, okay, decoding, okay. Hey, so another thing I was hoping for with this whole streaming protocol thing was that in certain encoding methods, they are usually recording changes over multiple frames rather than recording the entire frame. This results in much smaller data. The issue is I don't know how that would work. No, I'm not going to say issue. I was hoping I would be able to set up something like that here as well. Just so, as well, where the data is encoded on the ESP32. Actually, yeah, it was mentioned that encoding on the ESP32 would be a little heavier. But wait, okay. Encoded on the ESP32, sent over the network, and received and decoded on the PC before being displayed. You also mentioned that encoding on the ESP32 could be too heavy. What if I involved another ESP32 into the mix specifically to handle encoding and networking? So the ESP32 cam would capture frames and send them to the encoder ESP32, or let's say ESP32 encoder, over a parallel bus, and then the data gets encoded and sent over the network. Or would this whole setup just be unnecessarily convoluted and possibly also introduce further delay. Also, there was one last thing I had to ask. What was the last thing? Hold on, hold on. What was the last question that I had? There was one more question that I had. Hold on, hold on. It's gonna come to me. ESP32, send, connect the thing, send it. Okay, okay. Oh, yeah. Also, for communication, I was wondering how well would it work if I sent the data over WebSockets? Over WebSockets instead of raw sockets. Would there be a significant latency? Okay, that's a very sharp observation. When you're describing, what you're describing is interframes, what you are describing is interframe compression, like H.264, where the encoder only sends the difference between frames. This is significantly more efficient than MJPEG, which sends a full keyframe every which sends a full keyframe every single time. However, doing this on an ESP32 brings some major trade-offs. The two ESP32 solution, is it worth it? Adding a second ESP32 to handle the encoding sounds logical, but it's likely unnecessarily convoluted. The bottleneck, even if you offload the work, the transfer from ESP32.1 to ESP32.2 becomes your new headache. Parallel buses on these chips aren't standard high-speed interfaces like PCIe. You'd likely use SPI or I2S, which adds latency and CPU overhead just to move the raw pixels between the chips. The better hardware. If you want hardware H.264 encoding, the ESP32P4 is actually the answer. Unlike the classic ESP32, the P4 has a dedicated hardware H.264 encoder that can handle up to 1080p at 30 FPS. Let me see how expensive this is, because I kind of feel like it's not going to be cheap, or at least not as cheap as the regular ESP32s that I buy. You know what? I'll say this, it's not nearly as expensive. What is, no, hold on, just a second, dude. Wait, this is crazy. This thing comes with like massive, dude, what? ESP32P4 module core board, PS RAM, 32 MB flash, 16 MB, there's something else there, and ESP32C6. What am I looking at here? Because this looks like a full-on like Raspberry Pi kind of thing, dude. Okay, hold on. Give me a second. Let me take a sip of my energy drink and also drink some water. Wait, this is crazy. This says dual chips. I need to look into what this means because this says ESP32P4 core with C6. Like, what exactly does that mean? I'm kind of confused about what's going on there. And this looks like a Raspberry Pi, dude. This thing, it has like the usual GPIO pins. It has small like USB Type C ports. It also has the regular USB ports, two regular USB ports. It also has what looks like an Ethernet port, And it also has I don't know what you call these things. It has ports for putting in like those what do you call them? It's like traces of what do you call those things? It's like a flat plastic kind of thing with trace lines. You usually just like slip that into this connector. Those are connectors by themselves. You usually slip them into this thing and you lock it up, and that's the way that you connect the wire. It's usually not one wire. Generally those kinds of connections are parallel connections. So a lot of times you'll be seeing those kinds of connections when an LCD or LED or some other sort of display is being connected into something. It looks like a it looks like just like a flat plastic kind of thing, and there's traces of copper in it. So it's like a parallel bus. But anyways, I need to look into this, dude, because this is not that expensive. It's still not. I don't think. Okay, I don't know for sure though. Like whether I would be able to run a smaller OS on this thing, but this is not that expensive. I'll say that. Now let me look for just ESP32P4, because the other one I was looking at, it had both. Hold on, I didn't hydrate. I just drank my energy drink. Give me a second. Okay, dude, this is interesting. Like the development boards for ESP32P4, at least like the big ones that I'm looking at, they are coming with a bunch of peripherals that you would usually not get in one of the smaller ESP32 development boards. So you're getting stuff like an Ethernet port, you're getting bigger USB ports. I'm guessing they have like the communication protocol set up for that as well. Um, and I'm assuming it's a hardware-based implementation of the protocol. I think I'm also seeing like an audio jack. So this is great, dude. Like if you want to set up something, this becomes like a nice general purpose kind of thing. That being said, just for this one purpose, I can't justify buying this. As great as it is, I can't justify buying it. Because this is costing me, how do I convert this to dollars? So $10 would be that much. This is costing me, we can say anywhere between 15 and $20 just for that one board. And I can't really justify buying that right now. I just don't have the money for that. Okay, anyways, carrying on with this. The P4 has a dedicated hardware H.264 encoder that can handle up to so and so, so and so. The catch, the P4 doesn't have built-in Wi-Fi, so you'd still need a Wi-Fi coprocessor like an ESP32C3. And that is why this is coming with dual chips. That makes sense. Well, Gemini didn't say that that's why it's coming with dual chips. I'm saying that that's probably why it's coming with a dual chip, just so um, it has that Wi-Fi capability. Okay, standard software encoding. If you stick with your current ESP32 CAM, Espressif recently released the ESP H.264 component performance on an ESP32S3 software-based H.264 encoding is limited to about 320 x 240 at 11 fps. The reality, MJPEG is actually optimized for these low power chips, because the hardware does the heavy lifting. The sensor outputs a compressed JPEG, so the ESP32 just acts like a delivery boy. I didn't know that there's compression going on there as well. That's interesting. Okay, WebSockets versus raw sockets. You asked about latency with WebSockets. The answer is it's surprisingly good, but with one major caveat. Oh, raw UDP sockets versus WebSockets. WebSockets is over TCP. Okay. Latency. Raw UDP sockets would have the lowest latency. There's no handshake, no retries. WebSockets would have low latency, tiny overhead after the handshake. Reliability. Fire and forget. Frames may drop. And WebSockets, it's reliable. It retransmits lost packets. Overhead with raw UDP sockets is minimal because it has minimal headers. And on WebSockets, it's HTTP-like headers plus TCP overhead. Raw UDP sockets rust ease is moderate. You need to handle packet loss. And on WebSockets, it's very easy with crates like Tungstenite. I've heard this name before, Tungstenite. I don't remember where I've heard this, but yeah, okay. The lag risk, the real danger with WebSockets isn't the protocol speed, it's TCP congestion control. If your Wi-Fi hiccuped for half a second, TCP would try to catch up by resending everything. This causes the video to speed up. Yeah, okay, okay. This causes the video to speed up or buffer. In a webcam scenario, you usually just want to skip the lost data and show the newest frame immediately, which is why UDP is the gold standard for streaming. Okay, so here's some things I'm concerned about. Do I have to write the entire logic? The answer for this is most probably going to be no. There's probably going to be crates that handle this for me, but I kind of want, you know, Gemini to give me an answer. More specifically, not clients. I'm more concerned about the server side of stuff because I don't want to have to write an entire server loop because there's a lot that goes into that. The entire logic for the client and server. Yeah, do I have to write the entire logic for the client and server, or are there crates that make it easy to just set up a client on one end and set up a server running a loop on another end? Then the HTTP, what was it called? Magic Pack? What was, hold on. X Media Pack? Was the word magic even, oh, sorry, hit the thing. Was the word magic even in the thing? Hold on, give me a second. Multipart, yeah. The HTTP multipart X mixed replace thing. Okay. Yeah, the HTTP multipart thing works great if I'm displaying this in a browser. But how well would this work if I'm planning on setting up my own app to display the received images? I'd imagine I forgot where I was going with that. Own app to display the received images. Also, is there some sort of standard protocol to wrap these frame packets into something that mentions frame related details, or would I have to wait frame related details like frame index, etc., or would I have to create my own simple wrapper struct for that? Okay, to answer your concerns directly, you are touching on the exact line where DIY meets standardized protocols. Are there crates for this? Yes and no. In the Rust ecosystem, you have high-level crates, but because your project is split between a constrained device, such as the ESP32, and a PC, the glue usually requires a little manual code. That makes sense. That makes sense. What I'm hoping for here is that something that's gonna kind of the ease the issue of, difference between both the platforms is that they're both communicating over UDP. So that's literally all they have to worry about. And then on my end, yeah, definitely for the ESP32, I might need to use separate crates. For the PC, I might need to use separate crates. Definitely not complaining about that. I fully understand the need for that and the reason for that. I totally get it. Okay, on the PC side, which is the receiver, you don't have to write a raw loop from scratch. You can use Tokio for the networking. If you use HTTP MJPEG, you can use requests to stream the bytes and a crate like MJPEG RS or a simple boundary splitter logic to extract the JPEGs. Okay, on the ESP32 side, which is the sender, you use the ESP32, you use the standard ESP IDF or the Rust ESP camera wrappers. They often include a basic HTTP server example that handles the multipart headers for you. Then, HTTP multipart in a custom app. HTTP multipart works by sending a header, then the image bytes, then a boundary string, like frame. In a browser, the browser sees the content type and automatically replaces the old image with the new one. In your app will connect to the ESP32 via a standard TCP stream. Why is TCP involved if this is happening over UDP? Wasn't this supposed to be UDP? Okay, let's keep reading. You will read the stream and look at the JPEG. You will read the stream and look for the JPEG start of image and end of image markers. This is actually very fast and reliable for a GUI app. Standard protocols for frame details, the wrapper. If you want frame indices, timestamps, or resolution data with bundled with every packet, you are looking for RTP, real-time transport protocol. The standard way, RTP, this is the proper way to wrap video packets. It has a standard 12-byte header that includes a sequence number and a timestamp. The simple way, custom struct. For a solo project, creating your own wrapper is often easier. In Rust, you can use the bin code or zero copy crates to instantly turn a struct into bytes to send over UDP. Okay, yeah. Then displaying with Nano or simple GUI. For the GUI, Nano is excellent because it's built on WGPU, meaning it uses your GPU to draw the images, which keeps your CPU free for decoding the JPEGs. All right. How the loop works. Okay. Um, wait, I'm confused. You're talking about HTTP and MJPEG, but then you also mentioned UDP. If I'm dealing with raw UDP sockets, why exactly, why and how exactly am I wrapping this data into an HTTP packet which is being sent over TCP. Okay, this is a perfectly fair point of confusion. I was mixing two different standard paths. Let's untangle them completely. You have to choose one of them, one of these two paths. You wouldn't use both at the same time. Path A is the web standard TCP slash HTTP. Holy shit. This is what most out-of-the-box ESP32 examples use. The protocol, you use HTTP over TCP. How it works, your Rust app acts like a browser. It sends a GET request to the ESP32. The ESP32 responds with a never-ending HTTP response using the multi-part so-and-so header. The data inside the envelope is just one JPEG after another. Pros: very easy to test. You can just open your browser to the ESP32's IP. Cons: TCP ensures every byte arrives perfectly. If one packet is lost, the whole stream pauses while it retries. This causes video lag, where the image freezes and then speeds up to catch up. Okay, path B, the pro streaming way, raw UDP. This is what you should do if you want the lowest possible latency for a custom Rust app. The protocol, raw UDP sockets, no HTTP, no TCP. How it works, the ESP32 just blasts JPEG data to your PC's IP address. It doesn't care if the PC... This is where I'm glad that I actually took the time, and gonna be honest, headache, to try and learn how to work with bare bones sockets, because this is why I'm a little bit more comfortable with it now. And in this specific situation, this is going to be really helpful. Though, to be fair, this is one of the rare occasions where, just raw UDP sockets is probably going to be more helpful than, running over HTTP. Actually, wasn't there something that ran over HTTP but still used UDP? There was something. There was something. I need to remember that, because there was a thing where, yeah, I don't remember. Maybe it was WebRTC. I can't remember. Okay. Um yeah. The ESP32 just blasts JPEG data to your PC's IP address. It doesn't care if the PC is listening or if a packet gets lost. The data. Since the JPEG 30 KB is bigger than a single UDP packet, which is usually 1.4 KB, you have to fragment the JPEG. Okay. You have to fragment the JPEG on the ESP32 and reassemble it in Rust. Pros, zero lag. If a packet is lost, you just discard that partial frame and wait for the next start of frame signal. Cons, you have to write the reassembly logic yourself. How to wrap the data, the custom header. Since you want frame related details, index, size, so and so, path B is where you would use a wrapper. You aren't wrapping it in HTTP. You are creating a tiny binary header that sits at the front of your UDP packets. In Rust, it would look like this. Okay, you know what I could do? I would actually then have to write some sort of logic to, yeah, see, okay, this is where it the implementation starts to take up more time than, the actual building. Okay. Okay. You know what? I'll look into this once I get to that point. It should be um an interesting thing to set up, definitely. And I do wanna wait. I could send it in order, but the issue is that just because it's sent in order doesn't mean it's going to be received in that order. Like just because it's sent in a specific order doesn't mean it's going to be received in that specific order. I mean, obviously the receipt of it is not guaranteed, or the receiving of it is not guaranteed. But I also need to take the order into account. Okay, you know what? Okay, I just realized we have been streaming for how long? I think it's been a good like 45 minutes now, I think. Hold on, give me a second. Okay, open this up, open this up. We've been streaming for an hour. I was supposed to be looking into these the Rust basics and stuff, and we have not done any of that. Give me a second. I'm going to take a quick break, okay? And once I come back, we are definitely getting back to the Rust basics, and we are going to be exploring or continuing exploring um, traits, and maybe we'll get into lifetimes as well because we have a good like um, I'm able to go for another good like hour and 15 minutes or hour and a half. So yeah, yeah, we should have some time. BRB. Okay, I am back. Sorry about the delay. Um, okay, hold on. Give me a second here. I'm just doing something. Just need to set something up here real quick. Okay, so that's done. And now I need to go there and set the thing up there as well. All right. Now just one last thing remaining to do. All right, we are good to go. We can now continue. Man, my break ran a little longer than I expected. Also, this is crazy because like I started the stream early today, and even despite that, um, or even in spite of that, I don't know. Regardless of the fact that I started the stream early, we still didn't get to the main content of the stream. Which, to be fair, um, the main content, like, okay, hold on. I need to do this so I can scroll up, and hopefully now it's not broken. Yeah, now it's not broken. Now it looks proper. So now I can read out this thing. Okay, so back to what I was saying here. I had mentioned this thing about, um, me only being able to give like 30 to 60 minutes to this, to learning Rust per day. So I wanted Gemini to kind of form each of the chapters theory according to that, like keeping that limitation in mind. But I'm not really following that schedule anymore where I give like daily 30 to 60 minutes. As much as I would like to, it's just that my brain just doesn't work that way. I'm going to get distracted, and I just let myself get distracted because whatever I get distracted with, it's usually something else that's also productive. However, keeping that in mind, or that being said, even though I'm not following that 30 to 60 minute daily thing, just telling Gemini that okay, prepare the syllabus in such a way and all the content that you're generating, generate it in such a way that I can second here. I'm just loading up somebody's stream. Wait, we disconnected? Oh, you're joking. You are joking. The stream died. No, did the stream die? I mean, we are still at like, I mean, the timer is still saying 1 hour and 26 minutes. But in OBS, it's doing that. Well, maybe in OBS it disconnected, and then the Twitch disconnect protection took over. And because of that, it probably got saved. Hell yeah, dude. Okay. The stream didn't break apart, so I'm happy about that. Give me a second. Yeah, okay. So, um going back to this, I had said that um we're already done up to chapter 5. So we'll continue from chapter 6. This is how I'd started this conversation because this was a new prompt that I had to set up. Again, I can't remember what the reason was that I had to set up a new prompt, but yeah, we started from chapter 6 and then we continued. And now we are on chapter, actually, we can, yeah, since we are up here anyways, we are currently on chapter 9, I believe, which is traits. Prior to this, we did generics. Um, wait, hold on. Yeah, we are currently on traits. Prior to this, we did generics. Prior to that, we did collections, which involved vectors, strings, and hash maps. And earlier, I was kind of trying to refresh my knowledge on generics and on hash maps. I still kind of need to do a little more refreshing on generics because there's just so much that you can do with generics. I don't think I'm going to cover all of it, obviously, but yeah, I do want to mess around with generics as much as I can. And now we are currently in traits. So I got done reading, I believe, the theory portion of traits. Um, I'm gonna start reading it again, anyways. Doesn't matter. Because traits and generics, when you combine them, then you get something really powerful because you can do stuff like, okay, um, this so and so function takes so and so generic type. However, it's necessary that this generic type implements so and so trait. I was about to say crate. Yeah, it's important that this type implements so and so trait. So that way you can still limit what kinds of types can be used in this generic. And that's really powerful functionality that actually gets used quite a lot in Rust. I've seen it in like plenty of different situations, but I never actually implemented it myself. And so I don't, you know, each time I see it, I don't, I wouldn't always recognize that, oh yeah, this is what I'm looking at. You know, it's like it's a generic function or a generic struct. And even though it's generic, they still manage to limit what kinds of types can be passed into this generic, or what kind of type the generic can be. One good example here was when I tried to give me a second here. So I tried to create this function just for the sake of an example. I tried to create this function, right? I'm gonna remove this. I believe they call this a trait bound. And this was an older concept in Rust. I remember when we were reading the Rust book, like when we were studying through the Rust book, they had mentioned this, that there was a older concept of trait bounds in Rust, and there was a more verbose way of writing it, and then they introduced syntactical sugar at some point. You know what? I kind of wanna revisit that conversation real quick, just because we are currently talking about traits. Hey, I'm currently learning or relearning about traits in Rust, but this kind of reminded me of something called trait bounds in Rust, and also something about how there was a more verbose way of writing things before, and then later they introduced syntactical sugar for that. Um, do you know what I'm talking about? I'm pretty sure Gemini knows what I'm talking about. Do you know what I'm talking about? Okay, it sounds like you're thinking of the transition from trait bounds to impl trait syntax. That might be it. It's a classical aha moment in Rust because it takes something that looks quite academic and makes it feel much more like natural code. Okay, here's a breakdown of the verbose way versus the sugar way. The verbose way was trait bounds. Originally, if you wanted a function to accept any type that implements a specific trait, like summary, you had to wait. Hold on. Did they describe? Okay, yeah. You had to use generic type parameters. Um, I'm gonna copy paste the code here just so you guys can see it as well. So this is the verbose version. I'm not sure what summary is supposed to be. This is probably gonna throw an error. Yeah, that's okay. That's okay. Um, right. So what is this saying exactly? Hold up. Cannot find trait summary in this scope, not found in this scope. Okay, are there any like suggestions or something? Replace name generic with impl trait. Okay, back up. Okay, in this version, T is a placeholder and summary is the bound that restricts what T can be. This is very powerful, especially when you have multiple arguments of the same type or complex relationships. Sorry, zoned out. Okay, the syntax, the syntactic sugar, impl trait. Rust later introduced impl trait syntax. This is the sugar you this is the sugar you're likely remembering. It allows you to skip the T trait declaration and put the requirement right in the argument list. So that is this, the sugar version. Sorry, zoned out. Okay. Um, the sugar version. Okay. All right. So what is this saying exactly? I'm still confused about this. Let's create a trait here. There is nothing extra to do, right? Okay, item dot summarize. So there has to be a summarize function. Okay, let's do trait summary. I don't remember how to create traits. Yeah, let's say summarize, and this I believe should take this, and I don't know what this is supposed to return. We can get it to return something like that. Would we need like a lifetime here? Yeah, okay. Yeah, let's do that. Previous definition. Okay. So we can do this, and then this is what it looks like. Okay. And then we can do this, and this is what it looks like. All right. So here what it's saying is whatever type we are passing in, it has to implement this trait, right? So let's do struct some struct O1, I don't know, A I32, then struct some struct O2, A I32, and then we impl summary for some struct O1. Do we get, yes, okay, we get autocomplete here. So here we are creating the implementation. I don't remember if we actually need to provide a default implementation here. Can we just do this? Some struct O1 is defined multiple times. I think I've done that up here maybe. Yeah, okay, we can get rid of that. Though that might cause an issue here somewhere. No, this is some func. No, I think we are good. I think we are good. Also, oh wait, give me a second here. I just need to do something. Okay. Okay. All right. So, yeah, I was mentioning this previously that I don't know if I mentioned that I was able to get um, a sort of code completion thing. So over here, I tried to create a generic function, right? And what I intended was for an integer or a float to be passed in, and then it'll be well two integers or floats to be passed in, and then they'll be added, and the result will be returned. So then it also returns, t. It takes in two t's and returns a t. But then it turns out that you run into this issue. You cannot add t to t, and I think it's because I've never explored this concept before, so that's probably why it didn't occur to me. I think you have to implement the operators for different types. Like if you have a complex type, or a custom type that you're making, you have to implement the operators for them before you can actually use the operators. At some point, I should explore that part as well, just to see how that whole thing works. But the good news here is that I was able to get this through code actions. I was able to just add this in here. So I believe it's the Rust analyzer. I'm not sure what exactly it was suggesting. Wait, we can find out here. Consider restricting. This might be I I don't know if this is from the Rust analyzer or if it's from Clippy. Yeah, I keep getting confused about like what all exactly Clippy does. I believe Clippy does a bunch of um, a bunch of static analysis, and to a certain extent, it kind of runs the code as well. I believe to analyze it again to a certain extent. But then Rust Analyzer, yeah, yeah, I'll have to have a conversation with Gemini about this because I keep forgetting what specifically does Clippy do and what specifically does Rust Analyzer do. I know Rust Analyzer gets used a lot in the language server itself. Um, but like other than that, what Clippy and Rust Analyzer do, they kind of overlap sometimes. So the yellow thing I believe is from the Rust Analyzer, and the purple thing is from Clippy, but I can't remember. Again, I can't remember which one is for which. You know what? I could open up a new conversation here. Um, I do Rust coding in NVim, LazyVim. I've forgotten what exactly I wrote. Forgotten what exactly Rust Analyzer does and what Clippy does. Okay, it's easy to get. Oh, one more thing. Clippy is responsible also for catching bad programming practices, catching situations where you can improve the code, make it a little more optimized. And I believe even this thing that I'm getting, this suggestion, consider restricting type. Actually, wait, let me read the whole thing out. Here, diagnostics related stuff. So consider restricting type parameter t with trait add using so and so. I believe this is also being done by Clippy. So yeah, like I was saying, we get a code action here, and we can just add that code action, and then well, we can select that code action, and that basically adds this sort of limitation for which types can actually, you know, be passed into this, and then this works. So basically, I guess what we are saying here is that any type that implements this add operator, that can be passed in to this generic function. Now, let's go back to this. Yeah, it's easy to get those two mixed up because in a modern setup like LazyVim, they work together so seamlessly that they feel like a single tool. Think of it this way: Rust Analyzer is your brain for writing code, IDE features, while Clippy is your mentor for code quality or linting. Yeah, there you go. Rust Analyzer is the language server um, that does a whole bunch of things. Okay, cool. And then Clippy is the linter. It's a collection of over 700 lints. It doesn't care if your code works. It cares if your code is idiomatic and efficient. All right. Yeah. Wait, what all did it say? Because I know the Rust. I know that the whole IntelliSense thing is only working because of the Rust analyzer and the language server itself. So that's definitely something that's the heavy lifting that's done by the Rust analyzer, not by Clippy. But okay, let's not get too distracted with this. Going back to the syntactic sugar. Okay, Rust later introduced impl-trait syntax. This is the sugar you're likely remembering. It allows you to skip the T trait declaration and put the requirement right in the argument list. Sorry, zoned out. Okay. Put the argument right in the um, put, wait, declaration and put the requirement right in the argument list. All right, let's see an example of that here. Okay, so here we are doing the implementation, and here we should return the thing. Summary is never used. What do you mean summary is never used? I'm using it down here. Am I missing something? Summary is being used. Because if I remove this, we would now be getting an error because cannot find trait summary. That's interesting. Oh, is it because there's no type that's using is it because there's no instance of a type that implements the summary crate? Like let's do let C equals sum struct O1, and we can say A5. Okay, are we still seeing this error? Yes, we are still seeing it. I'm confused about why that is. Yeah, I'm confused about why this is. Hold up. I can probably, how do I copy this into the buffer using, wait, tmux scroll buffer block select. Oh, it's copy mode, right? Okay. To select a block in the tmux scrollback buffer, enter the copy mode, prefix plus so-and-so or control B plus so-and-so, then use Y style keys, Shift V or Control Space to start the select. I've only ever done space. Okay, let's try that here. Okay, so each time I do this, I press space. But the problem is with space, it's like anywhere within this buffer, right? Maybe not the empty segments, but like wherever there are characters, it's going to go everywhere, and that includes this line number and this icon and the space in between and stuff like that, right? So am I able to do, what did they say, shift V or control space? Control space doesn't seem to work. Shift V doesn't. Okay, Shift V becomes like a line based thing. Could I do, would Control V work here? No, Control V doesn't work. Control space to start a selection, move the arrow keys, okay. Okay, I think I can have this as a separate conversation with Gemini. Just a second. I have to do something. Okay. Back to this. Back to learning about like the trait bound thing. Give me a second. Okay. Actually, give me a couple more seconds. Let me drink some of my energy drink and also hydrate, and then I'll continue reading. All right. So back to reading this. So it allows you to skip the T trait declaration and put the requirements right in the arguments list. So the difference between these two. Wait, what's going on here? Okay. The difference between these two. Wait, hold up. I just realized something. If I do this and then I open up this, I'm not able to go down here, but I can scroll back up as much as I want. Also, the scroll back buffer, yeah, okay, it's a different kind of thing. Right, so this whatever we are seeing here, this section is being handled by NeoVim right now. And then you have this, which is what it looked like when I was trying to run the program. And I think you had this section. This might have been a separate thing as well. I think so. I might be a bit wrong here about this, but yeah, the point is all of this is within NeoVim itself. So like this is a different scroll, this is a different buffer than that scroll back buffer. Dude, it is so interesting. Like I'm so glad that I jumped into like terminal based or well yeah, I did jump into it. I dove into it and I switched the majority of my workflow to be primarily terminal based because it has blown my mind and it continues to blow my mind just how efficiently developers have managed to use this simple yet incredibly sophisticated and powerful thing called terminal, called the terminal, just terminal, whatever. This incredibly sophisticated thing, simple yet sophisticated. Like it's a simple thing that displays text on your screen, right? But it gives you a bunch of sophisticated functionality, because of which you're able to implement a whole bunch of very sophisticated applications that use this simple functionality in sophisticated ways. It is crazy. It is crazy, dude. Like so many different things that are possible within this very simple terminal. There's so much functionality. Like NeoVim is a great example. NeoVim alone is a great example. Within this one screen right now, I'm able to switch buffers so I can have different files open. Within this, I can also open this sort of explorer list. I can also have separate UI popping up. That's dude, that's crazy. Also, this is just within NeoVim, right? This NeoVim instance is running in a shell that is running in within one tmux window, right? So I can switch tmux windows, and this is all again happening within the same terminal. It's using the exact same terminal to just switch out what you see and what you don't see. It's basically showing you different slides or different workspaces that you can work in. All of this happening within one terminal window. That's insane, dude. Anyways, enough gushing about how cool the terminal based workflow is. And let's get back to this. So over here, we had trade bound, right? Okay, the issue was that it was limiting T to this. And I think if we wanted a V, or let's say U, we would have a different sort of thing for that as well. We could specify different limitations there as well, right? But then once they introduced this new way, so the old way was called a trade bound, I'm assuming, or a trade boundary. Trade bounds, yeah. Originally, originally, if you wanted a function to accept any type that implements a specific trait, like summary, you had to use generic type parameters with bounds. And this is the bound. So in this version, T is a placeholder and summary is the bound that restricts what T can be. This is very powerful, especially when you have multiple arguments of the same type or complex relationships. Then, syntactic sugar. Rust later introduced impletrate syntax where did I read where? No, Rust later introduced impletrate syntax. This is the sugar you're likely remembering. It allows you to skip the trait declaration and put the requirement right in the argument list. All right. Now, for this thing, what did Rust do? It used the trait bound thing over here. Okay. Now hold up. Hold on just a second. Um, this is much more readable. This, as in what I'm reading, is this version right now. So let's get rid of this version. So this. Oh, that's interesting. Hold on. This doesn't even mention generics. That is interesting. Okay. Okay, this is much more readable for simple cases. It effectively says, I don't care what the specific type is as long as it implements summary. The in between where clauses, that's what I've seen. Where. This is actually a third way. No, there is actually a third way to write this that sits between the two, where you have many traits or long type names. The verbose way gets messy. No, when you have many traits or long type names, the verbose way gets messy. Rust provides a where clause to move the bounds out of the function signature and keep things clean. Okay, so we have the impletrate, which is syntactic sugar, and then we have inline bounds, which is this, and then we have the where clause where we create a generic, okay, and then we specify where T is trait. So this is a new version that they showed. Notify T item T, is that what they mentioned? T item T, okay, where T implements summary. Does that work? Let's comment that out. Yeah, there we go. So this is the where clause. Why use one over the other? Use impl trait for simplicity and readability in most function arguments. Use trait bounds when you need two arguments to be the exact same type. For example, fn compare, okay, it ensures that a and b are the same type. Okay, yeah. So in my case, when I was doing this, when I was creating this function, then that's exactly what it did. It added the trait bound. For example, so and so, so and so, okay. Whereas so and so would allow, wait, hold on. Ensures A and B are the same type, whereas this would allow A to be an integer and B to be a string. Oh, that's interesting. Hold on, hold on. This is interesting. So what Gemini mentioned is that, okay, let's redefine. Okay, let's define a new function here, right? If we do this, right, and then I do a t and b t, and then I also return t. I'll just do add. Actually, will that work? That won't work. Let's just return a. Yeah, that's fine. So we want this traits for types that form a total order. So we want this ORD crate to be, or this ORD trait to be implemented in the type, right? But apparently this makes it so T can only be one type, and that one type is going to be applied to both A and B. So if A is an int, it's going to expect B to be an int as well. However, if you remove the trait bound from here and instead make it make this impl ord and impl, did I get rid of the, yeah, and impl ord again, mismatch type. Oh, actually, yeah, I don't need this, right? So I guess I could also get it to return an impl ord here. I didn't think about that part. But yeah, okay. So in this situation, this looks like it might be the same as, what we had done previously, where it was a trait bound that was being applied to all of the parameters, all of the arguments. But in this case, what this is saying is that A and B can both be different types as long as both of those types implement the ORD trait. And then you can probably even return a different type that also happens to implement the ORD trait. This is crazy, dude. No, this is crazy. This is actually crazy. And I think this is probably going to come up in this chapter that we are learning right now, the traits chapter. This is probably going to come up in the traits chapter. Okay. Right. Okay, I'm curious about something. Um, okay, let's try something here. Um, I want to purposely make this complex. Okay, so we're gonna do T and U, and here Now I wanna introduce the where clause here on purpose. So okay, what if we do it in this way? I haven't yet specified the thing, but we are gonna do where t ord and where I don't know how to add a second where u ord. So I'm just like doing stuff here. Oh, maybe the where thing is not necessary. Yeah, where is not necessary. And then the issue here is the return type. So return type should be specified after the function parameters. Oh, all right. I was concerned with that dine word there. So I was like, okay, maybe they want us to hold up. So immediately after the parameters, right? And okay, let's do that. Does that work? No, we are back to the same. Okay, hold on, dude. Right. Why did we get rid of the entire thing? Okay, there we go. And paste it. Okay, input ord, can't find type T. Right. Hey, so I'm wondering how you would handle situations where there are two types or two generic types and you need two where clauses. Okay, when you have multiple generic types, the standard inline syntax, the one with angle brackets, can get very hard to read very quickly. This is exactly where the where clause shines. You can handle multiple generic types by listing them in the angle brackets and then defining their, oh, give me a second. Okay. You can handle multiple generic types by listing them in the angle brackets and then defining their requirements in the where block separated by. So is that the mistake that I made here? I didn't specify this. Oh, that was the mistake that I made. Okay. So, okay, this is one way, right? Let's do another one. So let's do sumfunc04. Okay, let's say A, if we are defining the, so some of our options here, right? Let's say we are only taking one thing here. One of the options is this, right? That works. Another option, if we need like a specific trait bound, is okay. In this case, we have summary, right? Okay, we can do ORD, right? ORD, that works great. One of the problems you have here is that it's going to apply if you have multiple parameters that are supposed to take um, types that implement ORD for them, but still take separate types, not the same type. Then you run into an issue here that T is expected to be, that. Um, one solution is to do this, I guess. And then we can have it in this way. Another solution, instead of doing this, is that we don't use generic parameters at all. And hold on. Instead, we do impl ord here and impl ord here. So that works as well, right? And another way to do this thing, so let's get rid of the U there. Another way to do what I'm doing here, let's also return T. Okay. Another way to do this, I believe the where clause has to come here. Where T ORD. So that's another way of doing this. Okay. All right. All right. I'm kind of getting it. Right. The cluttered way, which is inline, is if you try to do this inline, the function signature becomes a wall of code that pushes the actual function name and parameters off to the side. That is true, actually. I did not take that into account. That is very true. Yes, because if we make it long and we have like multiple parameters, it can push everything off to the side. However, if we try it this way, then we can do A this, B that, and we can say T implements that, and U implements this, and that way our signature is still relatively, small. We can also add in extra things here, like the debug thing. So this way we can have like multiple traits. We can say we wanted to implement this trait and that trait and that trait. Hell, maybe I can even throw in summary. Yeah. And if this exact same thing was being done up here, let's try. Yep. There you go. If we did that and we did this, already our, let's delete this. Already our function name is like way too long. Our function signature is way too long. With the generic parameters being described like alone, the thing becomes way too long. So it kind of seems like if there are traits involved, if the generic I guess the right way to say this would be if the generic parameters are meant to be trait bound, then you should use the where clause. Hold on. If you try to do this so and so, that pushes the actual function name and parameters off to the side. The clean way, multiple where clauses. With where clauses, you separate the types from the constraints. You simply list each type on a new line or separated by commas after the function signature. Okay. All right. I'm curious about the vocabulary as well. Hold on. Would it be right to say that Yeah, no, hold on. I'm trying to get the vocabulary um, surrounding this right. Let's, no, hold on. We can go based on the example that was given. Would it be right to say, okay, keeping in line with your examples, would it be right to say that T is trait bound and requires the display and clone traits to be implemented? Implemented. Okay, hold on. Impli I'm fucking up this spelling so bad. Implemented. Okay. Um, and clone traits to be implemented, or would it be more accurate, or would it be right to say debug, not debug, did I say debug? No, display and clone are trait bounds. I think the latter seems more accurate to say, but let's find out. Are trait bounds for T. In the world of Rust, the second way you phrased is the technically accurate one. Display and clone are trait bounds for T. To help you nail down the vocabulary like a pro, here is the breakdown of how these terms are used in the community. The bound is the restriction. Think of the word bound as a limit or a requirement. The trait, display, is the bound. The type T is the generic type parameter. Correct phrasing, the type parameter T is bounded by display, or display is a trait bound on T. Okay. Anatomy of the syntax. Okay, hold on. Right. If you were explaining this code to a colleague, here's how you would label each part. T is the generic type parameter, summary is the trait, semicolon, no, colon summary is the trait bound, and then T colon summary is the generic clause or type parameter declaration. Common verbs used in Rust. Oh, okay, this is interesting. Wait, when talking about this with other developers, you'll usually hear these three terms. Implement, my struct implements the clone trait. Satisfy, the type U32 satisfies the display bound. And require, this function requires T to implement debug. A note on multiple bounds, when you use the plus sign, it is common to say T has multiple trait bounds. You can think of it like a job posting. Uh, the type T is the applicant, and the trait bounds, display plus clone, are the requirements or qualifications the applicant must have to get the job or be used by the function. It kind of seems to me like of the three syntaxes, of the three generic syntaxes, generic parameter, declaration syntaxes, the one with the where clause might be overall preferred. Though it though I can imagine situations where someone might might want to use the impl syntax. However, even in that situation, for the sake of keeping the signature clean, using the where clause kind of makes more sense. You've hit on a very sophisticated point about quote unquote clean code in Rust. You're right that as a project grows, the where clause is often the gold standard for maintainability, but each style actually serves a slightly different philosophical purpose. Here's how experienced Rustaceans usually decide which one to use. The cleanliness hierarchy. Holy shit. The impl the I'm just passing through style. This is best for low complexity functions where if you have a function that just needs to print something, using a where clause is actually over engineering. True. You would be typing more in that situation. Is actually over engineering the signature and can make it feel heavier than it needs to be. This is best for short functions, public APIs, where you want to hide internal complexity and single trait requirements. Downside, you can't use it if you need to reference the same type twice. True. Okay. Inline. This is a standard generic. This is a standard generic style. This is the middle ground. It's the most common way to write generics in tutorials and smaller crates. For example, no, in tutorials and smaller crates. This is best for one or two generics with single bounds, example T as ref so and so. Okay, downside. It becomes a horizontal scroll nightmare once you add more than two traits. Then the where clause, the architect style. As you suspected, this is the most scalable. It separates the what, which is the function name and arguments, from the how, which is the requirements of those types. This is best for complex logic, multiple generics, and trait-heavy code. Major advantage, it allows you to indent and comment on specific bounds. Why not always use where clauses? While the where clause is the cleanest for complex signatures, there is one reason people still love impl-trait. That's the cognitive load of naming. When you use a where clause, you have to invent a name for okay, for the type. Okay. T, U, or rec. Okay. Sometimes naming the type adds more noise than just saying I accept something that implements this trait. I didn't even think about that. Yeah, you don't have to name the generic type if you're doing this. Okay, and then there's an example. All right. Okay. All right. Cool. So our answer has been questioned. No, our question has been answered. We have cleared our doubt about this, and we can, well, I mean, we kind of learned about traits here as well, because like we will eventually be going into, so like we studied about generics first, right? And we didn't necessarily go, I don't think we went into um, generics that implement specific things. Yeah, I don't think, yeah, I don't think we went into generics that implement specific traits. And I think the reason for that is because we hadn't yet covered traits. So now we're going to cover traits. And I believe first we're going to go into creating traits and, implementing the traits for specific types. And then we're going to go into generics, um, or creating trait bounds for generic arguments, generic function type parameters. Okay. So I was supposed to be reading this, but like, I mean, to be fair, we did do a bunch of Rust learning. I'm probably going to continue doing this off stream as well because I want to get through this. I want to finish the traits chapter. After the traits chapter, I'm assuming at some point later on we're going to go into um, we're going to go into what do you call it? We're going to go into trait bounds once we cover the concept of traits. And eventually, let me scroll back up here. Eventually, we are going to move on to lifetimes, which is, oh yeah, hold on. So here we have four topics: defining traits, implementing traits on types, trait bounds, and then derivable traits. I have not even touched that topic so far. I don't think I've ever even practiced that. So that's going to be something interesting to learn. But yeah, after this, we are going to go into lifetimes, which is a very interesting topic to me because I've looked into the concept of lifetimes, but I kind of feel like I don't fully understand how to work with lifetimes. I understand the need for lifetimes. The whole idea is that you want to give the compiler or Rust's memory safety system, you want to give it a specific lifetime for how long this thing is supposed to live. Whatever variable it is, whatever value it is, how long this thing is supposed to live. If you are creating situations where the compiler can't infer how long, or it's not immediately obvious to the compiler how long this variable is going to live, then you have to specify a lifetime so the compiler knows when to get rid of this variable. So far, that's what I've understood about the concept of lifetimes, but how to properly work with lifetimes, I haven't fully understood that yet. So I need to, I think I'm going to spend some time with this. And then we have the concept of closures and iterators. Both of these concepts, I've worked with them to a certain extent. I haven't done too much with them. Closures in Rust, basically, it's anonymous functions. It even mentions it there. And iterators, I've worked very little with iterators. I've used iterators, but I haven't implemented my own. So that should be interesting as well. And then we go into a very exciting side of Rust, which is smart pointers, where we get to look into stuff like box and RC and refcell. From what I remember, box allows you to put types onto the heap, things that would otherwise be allocated on the stack. It allows you to put them on the heap explicitly. RC, I believe, and this is just like what I studied about this before, because now it's kind of I'm just like, well, refreshing my knowledge, but also really properly learning what I learned back then. So I kind of have some past knowledge of this, some past information. RC, I believe it stands for ref counted. This allows multiple owners for this type. Oh yeah, it also mentions here for multiple ownership. I didn't even read that. And then ref cell for interior mutability. I don't remember much about ref cell, but I do remember about box and RC. Yeah. Ooh, after that, we go into something even more exciting, which is concurrency. Threads, message passing, shared state concurrency with mutexes and channels and stuff. And after that, we are basically at the end because a very Oh wait, no, no, no. Hold up, hold up. There's two more chapters after that. So after the concurrency thing, this is gonna get like exciting real quick after the next like two chapters or something. Um, the last two chapters are unsafe rust. That's like a whole other advanced thing. And finally, we have chapter 15, which is advanced features and best practices. This is where we go into stuff like macros and foreign function interface, which I believe this is where we'll be interfacing with external libraries. So I could look into how we would interface with like a C library or even interop with Python. I'm I'm curious to see how that works out because maybe once I do something, well, once I learn about this, maybe I might be able to level up my Python programming to make it so I could maybe offload heavier calculations onto Rust and still remain within, Python land. Because right now, if I want to do that, my very simplistic thinking, my very I don't know. I don't want to make it sound like I'm putting myself down, but like my very simple knowledge that I have of this, my very simplistic thinking of this would cause me to come up with an idea like, okay, we have one Python script running, we have a Rust binary running, and then they do IPC, inter-process communication, via sockets, or maybe shared memory if they are on the same if they're on the same machine, right? But what if I'm able to use something like this to offload certain calculations, certain heavier calculations onto the Rust side? I'll have to see how that whole thing even works. Like, is the program running? Is there a binary running, or is the library somehow being run on the Python end? What's the situation with multi-threading there? Like, what's going on? There's a lot that we can explore there. Oh, good. It also goes into testing best practices because we haven't touched testing in this specific course so far. But that being said, holy shit, dude, we've been streaming for 2.5 hours. That's amazing. I'm happy about that. Give me a second here while I look for somebody. Uh, Someone asked for a locked in department. Oh, holy shit, what is going on with my, that's crazy. Okay. Yeah. Um, just a second. I did find somebody, but I'm seeing if I can find somebody else as well. And then based on that, dude, I can't remember if I've rated this person before. Yeah, I can't remember. No, there was a person that I had rated before who was actually a STEM teacher. I haven't seen her on wait, this is interesting. Yeah, I haven't seen her in this category since then. I don't know if she just streams at a different time or if she's not doing like the co-working and studying streams. I don't know what the situation is. Give me a second. You know what? Okay. We're gonna go to this person. I don't know what they're doing. This person is doing co-working and studying. We're gonna go hang out there and see what they are up to. And I can now rest my voice because 2.5 hours is too much for me to talk, so I definitely need to rest my voice. And after some time, I guess I'll go cook something to eat. But I'm excited about the progress that we made. I'm happy with the progress that we've made today. I want to continue with this entire thing and maybe just grind out the entire thing for as long as possible and finish the entire course as soon as possible. But let's see how long it takes because there's quite a few topics to cover and more importantly, understand, not just cover. I'm not just trying to memorize everything. I'm trying to properly understand everything and practice whatever I'm learning. So that's kind of why I don't want to, completely just rush through it and then in the end I don't understand jack shit. Like it's going to be pointless, right? So yeah, I'm gonna continue with this, and and once we are done with these basics, dude, we're gonna go crazy. We're gonna go crazy with a bunch of Rust programming, both embedded and PC programming. I also need to take out the time to finish learning Zola, at least the Zola basics. But okay, my time is running out. I hope you guys have a nice day, and I'll see you all next time. Peace.